Well, I hope you can see how young we were, and some of us still are. And I'm sure you're all waiting to ask questions of the chair panel. But before we start, I'd like to invite Professor Larry Smarr, Director of Cal IT2, to say a few words about the future of our department. Larry, please.
Well, thanks, Vineet, and welcome to Cal IT2's Qualcomm Institute. We're still working on how to figure out all these different names, but one of the things that we've really enjoyed is being a partner with the department. In a sense, this building is the department's extended laboratories. And as we look forward to the next 25 years, you know, it's going to be incredibly disruptive. It's not going to be the same length of time. It's going to seem like a lot more years than 25 years, and this is because of this amazing convergence of nanotechnology, IT, telecom, and bio. So if you think about it, already, where are we seeing changes that are fundamental to where this department will have to go over the next 25 years? The very components we make computers out of. We're talking single electron transistors, carbon nanotubes, where quantum mechanics, instead of being an annoyance as we went to smaller and smaller scale, becomes the reality we have to build computers in. What are the design rules? How do you even think about this? Are you going to grow the computers? Will they be self-replicating components? How do you get up to the scale that we're used to out of things that we have no idea how to work with and which have properties physically that are completely bizarre by today's more or less semi-classical components? The scale that we're going to be dealing with. I mean, right now we have the beginnings of this planetary computer that Google and others build. Probably 1 million cores a year are just added. I mean, it's you know, you look out to where supercomputers are going to be by, say, 2020, the exascale. Well, because the clock cycles are timing off, this means this thing will be like 1 billion gigahertz computers. We'll say that each of those only has one failure a year. There's only 3 × 10⁸ in a year. So that's like 3 times a second you're going to have a failure. So you're going to have a completely different set of software, a different way of thinking about it, just to build in a room a exascale computer. But by that time, the distributed planetary computer is, you know, think it's really a global brain. If you think about your eyes are just neural extensions of your brain. If you think about all of the billion video cameras, microphones, accelerometers, not to mention the trillion or so Internet of Things that are coming, all interconnected to this cloud, which is at scales far exceeding the computing power of human intelligence. I mean, people's brains are, roughly speaking, somewhere around a petascale. Certainly by an exascale, you're going to be exceeding that. So, you know, I'm very excited to see this talks this afternoon, you know, talking about consciousness, talking about evolution. Think about how our department is led in this final frontier, which is going from engineering computers, which is what the last 25 years have been about, to biologically inspired computer science, which I think is mainly going to dominate the next 25 years. I mean, we've already had leadership throughout the department in understanding the information systems that make living things possible, the DNA that is in each of us, in every living creature, but also in our case, 100 trillion microbes that inhabit each of us, each of which are, say, 5 million bases of DNA long. From an information system, where's the computer science of that system? And then you begin to think about the brain. I mean, we've just got President Obama launching the Brain Initiative. One of the centers for that will be incubated in Cal IT2 here. You go to Qualcomm. They're talking already today about neuromorphic chips. Ralph Greenspan, the head of our brain center, was over there the other day. They want him to come back with a whole bunch of neuroscientists. So where's the computer science of biologically inspired computers? This is an entirely new field. We should be at the leadership front end of that. And one of the ways I think we'll do it is by the kind of capabilities that aren't just in the department, but are partnering out from the department through things like Cal IT through the neuroscience community, which there's more neuroscientists within, a mile or two here than anywhere on Earth. So this is, to me, this wonderful series of discoveries, of invention, of laying the groundwork of a computer science that looks nothing like today's, but essentially will be accomplished in the next 25 years. And so I look forward to this department taking a leadership role in that. We've got a great start, but there's a lot more to do. The students, imagine the students coming into these kind of questions. So it's going to be an extraordinary period. Just